Enzyme inhibitors. So looking at the biological molecules topic, this section 3.1.4.2, many proteins are enzymes. And we're looking specifically today at the effect of competitive and non-competitive inhibitors on the rate of an enzyme-controlled reaction. So competitive inhibitors have a similar shape to the substrate molecule, and this means that they compete with the substrate molecules to bind to the active site. So therefore they block the active site so no substrate can actually fit. How much the enzyme is inhibited depends on the concentration of the inhibitor. The more inhibitor, the slower the rate of enzyme-controlled reaction. If there's a higher concentration of substrate, then the substrate chance of getting to an active site increases. So increasing the concentration of substrate will increase the rate of reaction up to a certain point. So you can see here that this is without an inhibitor, but then this is with the inhibitor, but as you increase substrate concentration, the effect of the inhibitor comes less and less. And if you add so much substrate that it's really likely that the substrate is going to bind to the active site rather than the inhibitor. So the rate of enzyme-controlled reaction won't be affected so much if you've got a really high concentration of substrate. So competitive inhibitors, there eventually, as you add more substrate, the rate of reaction will equal that of without it. Whereas a non-competitive inhibitor will never reach the normal rate of reaction. So non-competitive inhibitors bind to the enzyme away from its active site, and this causes the active site to change shape so that the substrate molecules can no longer bind. So a non-competitive inhibitor binds at a site away from the active site, and that causes the active site to change shape so the substrate is no longer complementary to the active site. So a non-competitive inhibitor is where the molecules don't actually compete with the substrate molecules to bind to the active site because they are completely different shape. What they actually do is bind to a site away from the active site, which changes the shape of the active site itself. An increase in the concentration of substrate won't actually make any difference because the enzyme's activity will still be inhibited. So you can see here, this is the normal reaction without an inhibitor, and then this is with an inhibitor, and increasing the substrate concentration has little or no effect on the rate of reaction. So as a worked exam question from AQA, an enzyme catalyses only one reaction. Explain why. Well, enzymes have an active site, which is a very specific shape, and only the substrate fits, or only the substrate is complementary. Gout is a disease caused by the buildup of uric acid crystals in joints. Uric acid is produced from xanthine in a reaction catalysed by the enzyme xanthine oxidase. So the equation for that is xanthine is catalysed by xanthine oxidase into uric acid. Allopurinol is a drug used to treat gout. The diagram shows the structure of xanthine and allopurinol. Use this information to suggest how allopurinol can be used to treat gout. So you can see here they're quite similar in structure. So allopurinol is a similar shape to xanthine. Allopurinol enters the active site or is a competitive inhibitor, which means less xanthine can bind, or there are fewer enzyme substrate complex